Hello, thank you for watching this video. So in this video I'll be doing question 3 of November 2020 question paper mathematics paper 2. So I'll read question 3 statement and proceed to answer the questions that follow. So TSK is drawn, the equation ST is given, and ST casts the x-axis at M. W lies on ST and R lies on SK, such that WR is parallel to the y-axis. WK casts the x-axis at V and y-axis at P. KS casts the x-axis at N, and the angle S on TSK is theta. So let's break this down. So triangle TSK is drawn. TSK is it. The equation ST is given. The equation of this line is given, and ST casts the x-axis at M. It casts the x-axis at M. W lies on ST and R lies on SK, such that WR is parallel to the y-axis. So they are saying W lies on ST and R lies on SK, such that the line WR is parallel to your y-axis, so it is vertical. WK cuts the x-axis at V and the y-axis at P. So the line WK cuts the x-axis at V and the y-axis at P. KS cuts the x-axis at N. So the line KS cuts the x-axis at N, and the angle S of the triangle TSK is theta. We broke down the diagram. So let's go to the questions. Calculate the gradient of WP. So they want us to calculate the gradient of WP. So we have W, we have P. They want us to calculate the gradient of that. So you know, to find your gradient, you say, okay, your points first is WP, right? So it's minus 4 and 4, and your P is 0 and minus 4. So your gradient of WP is equal to y2 minus y1 of x2 minus x1. Let's say this is your x1, y1, x2, y2. So what do you have? So this is your 3.1. So your y2 is minus 4 minus your y1, which is 4, divided by your x2, which is 0, minus your x1, which is minus 4. So we have minus 8 over 4, which is the gradient is minus 2. So your gradient of WP is equal to minus 2. We're done. 3.2. Next question. Show that, they are saying, show that WP is perpendicular to ST. So they want us to show that WP, what is WP? This line here is perpendicular to ST, which is this line is perpendicular to this line. That's what they want us to show. So to show this, you must, so if two lines are perpendicular to one another, the product of their gradient is minus 1. So now what you have to do is to multiply the gradient of WP and the gradient of ST and see if you find minus 1. Then if it is minus 1, then those two lines are perpendicular. So if WP is perpendicular to ST, then M, which is the gradient of WP, times the gradient of ST is equal to minus 1. That's what that tells you. So now, if these two are perpendicular, then their gradient is that. So now, we must show the product of the gradient is that. So we must show that if you multiply the gradients of the two lines, then, and they give us minus 1, we must show that they give us minus 1. So, you have this gradient. So the gradient of ST, we are given that the line ST is equal to y is equal to 1 over 2x plus 6. That was the equation of ST. Then now the gradient of ST is 1 over 2. So the gradient of ST is 1 over 2. Right? So now what we must do is to multiply these two gradients, this gradient and that gradient, and see what it gives us. So if they give us minus 1, then we're done, because we know that if two lines are perpendicular to one another, the product of their gradient is minus 1. So now MWP times MST is equal to, is it equal to minus 1? That's what we want to check. If it is that, then we're done. Then these two guys are perpendicular. So the gradient of M of WP is minus 2. The gradient of ST is 1 over 2. Then punch this on your calculator. You'll find that your answer is minus 1. Therefore, we have shown that these two lines are perpendicular because the product of their gradients is minus 1. That's how you do this one. So we'll go to 3.3. I'm going to clean the board. Okay. So if the equation of SK is given as this, so you are given, so doing 3.3, the equation of SK is given as 5y is equal to 5y plus 2x plus 60 is equal to 0. So that is the equation of SK. If the equation of SK is given as that, calculate the coordinates of S. So we're given the equation of what? Of SK. They want us to find the equation of S. So we're given the equation of this line, ST. We're given as y is equal to 1 over 2 x plus 6. Right? Now they are giving us the equation of SK. So let's write it in the form of y. So say, okay, transpose these two to the side. So 5y is equal to minus 2x minus 60. Divide by 5, divide by 5, divide by 5. Y is equal to minus 2x minus 60 all over 5. This is our equation of SK, right? So what they want us to do is to find the coordinates of S, right? So now, here at the coordinates of S, this line SK and this line, this line ST and this line SK, they intersect there, right? So, here they intersect. The two lines intersect. So what do you know about the point of intersection? So when your two functions intersect, they have the same coordinates. So if you say your S here have x and y coordinates, so both of them here have the same x and the same y coordinates, which means the x coordinate of this line and the x coordinate of this line are the same, and the y coordinate of this line here and the y coordinate of this line here are the same. So they have the same x value and they have the same y value. So the y value of SK is given by this. The y value of SK. To find any value in SK, you use this equation. if you want to find any y value of sk, you use this equation. And the y value of that lie on the line st are given by, this is sk, this is st. So y is equal to 1 over 2x plus 6. So this line sk is defined by this line, and the line st is defined by that line. So at the point of intersection, right, at this point here, they have the same y coordinate. So the y is the same, and that y is the same. So here at this point, these y values are the same, right? So if you're saying they're the same, which means you're saying this y is equal to that y, which is yst is equal to ysk. Because here, they are the same, which means these guys at that point, they're exactly equal. So what you do, you just equate them, which means now it's going to be this line equal to that line, because they are equal at the point S. So here, both of them, they're exactly the same, they're equal. So what you do, you just equate them and solve for x. So I'm going to clean them here so that I can start from the top. So you know at S, right, your line y st is equal to your line y sk, right? St is equal to what? St is equal to yst is equal to that, which is 1 over 2x plus 6, which is equal to minus 2x minus 60 all over 5. So what you're trying to find here, you're trying to find your value of x, right? So let's solve for x here. The first step is to get rid, or is to solve this equation, which is now you get rid of your denominator. So you can first multiply by 2 both sides, by 2, which is now you get rid of this 2, then multiply by 5 both sides, right? So now what you are left with is, so you multiply by 10 both sides, that's what you're doing essentially, but this is 10, this is 10, so you're multiplying by 10 both sides. So 10 times this, you have 5x here, plus 10 times that, that's 60, is equal to 10 times this, so this and that goes away, you're left with 2, 2 times that, minus 4x, this time that, minus 120. So what do? We say, okay, we transpose this to the side, transpose that side, so you have 5x plus 4x is equal to minus 120 minus 60. So 9x is equal to minus 180. Then you divide by 9, x is equal to minus 20. That's your x value at this point here. Your x here is minus 20 here. So you have x minus 20. So to find your y value, you substitute this on this equation or that equation. They are equal there, so they will give you the same value. So let's use this one. It looks simple. So y is equal to minus 1 over 2 into minus 20 plus 6. So this times this, this is positive. This time that is minus 10 plus 6 equal to minus 4. So the y value here is minus 4. So the coordinates for S that were asked is minus 20 and 4. Straightforward. So let's go to the next question. So calculate the length WR, right? So they want us to find this length here, WR. So since it is vertical here, so you already know the x coordinate here, that the x coordinate is -4. The y value is what is missing, the y value. Because if this is a vertical line here, that is parallel to your axis, so your y axis, so your x value does not change. So it is -4 in x value here, which is this. So the only thing you are missing is the y value. So now you are given the line, the equation of this line, and this point is lying on this line. So now if you know the x value, you can find its y value, then you can be able to find the distance between the 2 points. So let's do this. 3.4. So 3.4. So they want you to find the distance WR, which is this distance here. So first thing you need to do is find the coordinates at this point, the y coordinate here, then you'll be able to find the distance between 2 points. But you know that this point lies on this line, right? So if you know the equation of this line, then you can find what the y value is. And you're given the equation of this line that y is equal to -2x minus 60 all over 5. Right? So you know the x value is -4, then you can put -4 there. -2 into -4 minus 60 all over 5. What is the y value? Punch that in your calculator. -2 into -4 minus 60 all over 5. That is 52 over 5. Our answer is -52 over 5. So that is the y coordinate of this line. So the y coordinate is -52 over 5. Then you can find the distance between the 2 points. So you know the distance between W and R is equal to x2 minus x1 all squared plus y2 minus y1 all squared. X2 can choose yourself. Let's say it's -4 here, -4 minus -4, which is this one here, plus y2, which is 4 minus that. 4 minus -52 over 5 all squared. Punch this on your calculator to get your distance WR. So when you punch it, it's -4 minus 4 all squared plus 4 plus 4 minus -52 over 5 all squared. Distance is 72 over 5, which is the same as 14.4. That's your distance. So you know the distance here. You know this distance here is 14.4. Let's go to the next question. So, next question, calculate the size of theta. They want us to calculate this size here. This guy, theta. Yeah, so there are different ways you can approach this. I'm not sure if mine is very fun. Let's see. This is 3.5. They want the value of theta. value of this guy here, right? So what I know the gradient of this line here. So I can find this angle of inclination here, right? And I know the gradient of this line, which means I can find this angle of inclination here. This angle here, this is alpha. So if I know alpha, I know the vertical opposite angle, which is this one here. And if I know beta I find what this is, I know the angle on a straight line adds up to 180, then I'll be able to find this guy here. If I find this guy here, I know what this angle is. So I will know two angles here, this angle and that angle. That means I'll be able to find this angle here. And now I know that the angles on a straight line adds up to 180. If I know what this is, then I'll be able to separate this from 180. That's the one that I think is easy for myself. So let me explain how I'm going to approach it again. So what I'm going to do is, okay, I'll say, listen, I have this gradient here. I'll be able to find this angle of inclination here. I have this gradient here. I'll be able to find that angle of inclination. Finding this angle is the same as this one. Knowing this, I know angles on a straight line adds up to 180. I'll find what this is. Then it's the same as this. Similar logic. Then if I know these two, I'll be able to find this angle here. And then now, since this angle is on this straight line, I'll be able to find what that one is. That's what I'm going to do. So I'm saying, okay, M is equal to tan theta, right? So I'm starting for, I will start with, what is this? ST. Start with ST. M is equal to tan theta. So our M there was 3 over 4, right? Sorry. No, it was 1 over 2. The gradient of this line, it was 1 over 2. 1 over 2 is equal to tan theta. So theta tan 1 over 2. Arctan 1 over 2. You press your arctan 1 over 2 on your calculator. Shift tan 1 over 2 is 26.6. So it's 26.6. So I know this angle here, 26.6, which is the same as this one here, 26.6. Then we go to the next one. Okay, so now what we're missing is one find beta, right? So we say, okay, M is equal to tan beta. What is our M? Our M is the gradient of this line NK or SK, which was minus 2 over 5. We're given this minus 2 over 5 is equal to tan beta. Then when you're here, going to find the reference angle for tan. So the reference angle, your reference angle is equal to arctan, which is tan. Arctan 2 over 5. You don't include the sign, because the sign is telling you which quadrant this is. So which is equal to arctan 2 over 5 is 21.8. So now your reference angle is 21.8 and the tan is negative. Which quadrant is tan negative? That is the second quadrant and the fourth quadrant, right? And we know that our angle here is an obtuse angle. So It's greater than 90 degrees. So now it makes sense for us to say our beta, which is on this beta of ours on the second quadrant. So it's going to be 180 minus our reference angle, which is 21.8. Right? So 180 minus 21.8, which is equal to 158.2 degrees. So we have our beta here to be 158.2. Then we can find this line here, this one here, because they are adding this angle and that one add up to 180. So to find this, it will be this angle here is called 180 minus 158.2, which is equal to 21.8. So this angle here is 21.8, which is the same as this one here, because vertical opposite angle, 21.8 here. So now we can find what this angle is, because the angle in the triangle add up to 180. So to find the angle here, we should make the angle NSM is equal to 180 minus these two sides. 21.8 plus 28.6. 28.6? Oh, sorry, it's 26.6. So M is equal to angle S inside this triangle is 180 minus 21.8 plus 26.6. This is 131.6. Is this angle triangle 131.6? Then you know that this angle and that one add up to 180. So to find what this one is, you must subtract this from 180. So our angle that we asked, theta, will be equal to 180 degrees on a straight line minus that. Then we'll be left with this. 180 minus 131.6, which is equal to 48.4. So our angle here, our theta is 48.4. So go to the next question, 3.6. So 3.6 read as follows. Let L be a point in the third quadrant. So they say L be a point somewhere here in the third quadrant, right? Such that SWR, in that order forms a parallelogram. So they're saying let L be a point here in the third quadrant, such that SW, R, and L forms a parallelogram. So you can say L is somewhere here because this one is vertical, which means if you want this to be a parallelogram, this side should be parallel to the side, which is this one here, and this one should be parallel to that side. So this one should be parallel to this, and this one here should be parallel to that. So this one is vertical, and that one is vertical as well. So you let L, let this be your L. So you let L be a point in the third quadrant, such that S, W, L, and R forms a parallelogram. Calculate the area of this parallelogram. So the area of the parallelogram, if you have a parallelogram like this, area is your base, which is the side, times your perpendicular height. So area of a parallelogram is equal to your base times your perpendicular height. Or you can say yeah, okay, it's fine. Or if maybe you say you have your base here and you are given this side here, A. So it will be your B times A. So you're also given the angle here, times A sine theta, which this part here is your perpendicular height, which is the same as this. So in this case, we know what this length is. It was 14.4, right? So we know this part, which is this part, the base, in this case 14.4 this side. We know that this side is 14.4. What we don't know is the perpendicular height, which is this part that we're missing. But we can get it because we know the coordinates of this point. The coordinates of this point are minus 20 and 4, which means we can go all the way here, right? So we know that the y coordinate here is minus 4. It's the same as that one. So here we have minus 4 as the y. The x coordinate is minus 4 and the y coordinate is minus 4. Because here we're getting the y coordinate, and when we get to this line, we also know the x coordinate. So we know the coordinates of that point, which means now we can find this distance here, which will be our vertical distance, which is this in this case. Because now look at this parallelogram as this one, but that is rotated 90 degrees to the right or clockwise. So you can find this distance here, distance between this point and that point. What is it? Distance between S and our point is equal to x2 minus x1 all squared plus y2 minus y1 all squared, right? Which is equal to x1 is minus 20 minus x2, which is minus 4 all squared plus y1, which is minus 4 minus y2, which is minus 4. Minus 4 minus minus 4. Punch this on your calculator. I'll punch this on mine. So you have minus 20 minus minus 4 all squared. This is 0. This is equal to 16. So to calculate your area is equal to your base, which is the side, which is in our case this side. This is 14.4. What was it? 14.4. Yeah, it was 14.4, right? This 14.4 is our base, 14.4, which was also 14.4 times our perpendicular height. Our perpendicular height is this one here, which is the same as this one here, which is just what we just calculated, 16 times 16. Our area is 230.4. So this is our area of the parallelogram. And we're done with this question.